Okay, we came back. Okay, now we up to question 10. Okay, question 10 says find the remainder when the polynomial p of x x cubed minus 3x plus 7 is divided by x minus 2. Okay, so far you should know that the answer for this question is very, very simple because we have a theorem. Okay, the theorem say in this case that if you are going to find the remainder, all you have to do is to evaluate that polynomial when x is equal to 2. Okay, that is exactly what we are going to do. Okay, so this is question 10. Okay, question 10. Okay, this is the polynomial p of x is equal to x cubed minus 3x plus 7. And we are going to divide that by x minus 2. So we divide that by x minus 2. But what we want is the remainder. Okay, so we're going to say from the remainder theorem, we have that p of 2 is the remainder. Okay, so let's find what the remainder is. So we're going to evaluate, this polynomial when x equal 2. So that will give you 2 cubed minus 3 times 2 and then plus 7. So that will give you 8 minus 6, which is 2 plus 7 equal 9. That's it. That's all you have to do for this question. Okay, nothing else. Okay, so the remainder when that polynomial is divided by x minus 2 is equal to 9. All right. So that was a very easy question. Okay, now let's see how we're going to do question 11. Okay, question 11. In question 11 we have find the remainder when x minus a bracket x plus a plus 1 is divided by x plus a. Okay, apparently this is another very easy question. So we're going to say let p of x, my polynomial, which is x minus I, and then x plus I plus 1. And we are going to divide that by x plus 2 and find the remainder, but we're not going to be doing long division. We're going to be using this theorem. Okay. So therefore, we're going to say the remainder is equal to p at positive 2. Okay, and then we're going to evaluate. So when x equal 2, then we're going to have that that polynomial is 2 minus a, and then we're going to have 2 plus a plus 1. Okay, so let me see. So yeah, we got everything right. Okay, so then wow. Okay, so get back. I was talking about this divisor, but we're talking about this. So we need to evaluate that when x is equal to x. All right. Minus a. Okay, start again. So we gotta find the remainder for this polynomial when this polynomial is divided by actually a plus a. Okay, so we are dividing by x plus a. And the remainder theorem says that the remainder is going to be equal to p at negative a. That's it. Now we are in the right track. Okay. And then we're going to substitute. So we're going to have negative a minus a, and then we're going to have negative a plus a, and then plus 1. And then, well, this is equal to 0, so it's going to be 1. So we're going to have minus 2a multiplied by 1, which is minus 2a. Okay, so that is the answer for that question. Another sort of easy question. Okay. All right, so please make sure that you remember, the remainder and factor theorem. In test, sometimes we're going to ask you, state the remainder theorem and then state the factor theorem. So you need to know, how to write it down, and then more than anything, you need to apply them. Okay. Now we're going to be doing question 12. Question 12. Okay, let's see what the questions say. They say the polynomial p of x has degree 3, so it's a cubic, and has factors x minus 1 in bracket square and x plus 2, and has a remainder of 40 when divided by x minus 3, and then they say that we got to find the polynomial. Alright, so what we know is this. So we know that this polynomial is a cubic polynomial, and we don't know whether it is a monic or a non-monic, so that's why we're going to put a at the front. And we know that x minus 1 in bracket square and x plus 2 are the factors, so that means that this polynomial looks like x minus 1 square and then x plus 2. Okay, so we got almost everything except for a, because we don't know whether it's a monic or a non-monic. If we knew that this was a monic, then we don't need to put that a in there, and the answer is only the product of these two factors. Okay, but we don't know. Okay, and then they say this. They say that when you divide this polynomial by x minus 3, the remainder is 40. Alright, so that means that the remainder is 40 when p of x is divided by x minus 3. All right, so in other words, what we are saying is that p positive 3 is equal to 40. That's what we say. Okay, and then we're going to be using this information to find the answer for a. All right, so we're going to substitute 3 in here, and then we're going to equate that equal to 40, and then make a the subject. So we're going to say then we had that a, and then 3 minus 1 square multiplied by 3 plus 2, that is equal to 40. Okay, so this part is this, and then equal to 40. All right, all what we're doing is just equating this to 40, and then we're going to find the answer for a. Okay, so from here we have 3 minus 1 is 2, a square is going to be 4, and then 4 times 5 is 20. So that means that 20a is equal to 40, so therefore a is equal to 2. Okay, so that's really good, because then we can see that our polynomial is equal to 2, and then x minus 1 is square, and then multiply by x plus 2. That's it. That's all what we need to do for that question. All right, so that was sort of easy question, but you need to fully understand how to put to use, the remainder theorem when you have a question like this. Okay, so you read the question and then you see how you can fit in, the remainder theorem, if that is the case, or the factor theorem. Okay, question 12. Now we're going to do question 13. All right. Okay, this is one of those questions in which you have, some unknown coefficients. In this case, the coefficient of x squared and the coefficient of x are both missing. Okay, but you have enough information to find them. Okay, so we need to find the value of a and b. And from previous question, we know that when we have a situation like that, then we're going to have to solve a simultaneous equation. Okay, so here we go. So we're going to call this question 13. So we're going to call px to our polynomial, and that is equal to ax squared plus bx minus 40. Okay, so in here we're talking about a quadratic polynomial. Okay, and then we're going to see what information they are giving us. So they say that the remainder is 12 when divided by x minus 1. So first piece of information is p of 1 is equal to negative 12. So that will give us the first equation.